if I write one-way arrow, what's the meaning? If I write H2 plus O2 react to make water, 2 moles of water. If I write one-way arrow, that means all of the oxygen and hydrogen, if they are proportion 1 mole of oxygen and 2 moles of hydrogen, react together to make water. That means there is no oxygen and hydrogen left over. Reaction goes to completion if I write one-way arrow. But if I write a two-way arrow, like this, it means reaction goes back and forth. That means you always have some product and mixture of unreactant reactants. That's what the meaning of equilibrium is. Equilibrium means reaction would never go to completion. It never goes 100% to the right. It goes back and forth. That means you always have some unreacted material. So in this problem, we are asking, at what temperature reaction is at equilibrium? It means at what temperature reaction is going to have delta G equal to 0. And you already have a formula. Delta G value under the standard condition is equal to delta H minus T delta S. That's the formula. If I am saying equilibrium, it means this must be equal to 0, right? That was the requirement. That was our definition for an equilibrium reaction. Guys, if I give you the value of delta H, which I have already given to you, and I give you the value of delta S, which I have already given to you, can you solve this equation, which is delta H minus T delta S is 0? Can you solve this equation for T? At what temperature this reaction is going to be at equilibrium? In other words, how would you solve this equation for T? Anybody make a suggestion? Can I move this to the other side of equation and write delta H is equal to, if I move negative delta S to the other side, does it become positive T delta S? Yes or no? What should I do to solve this equation for the value of T? Help me. Help me. Someone help me.
Divide by delta S.
Beautiful. Thank you. Brian, good to see you, Brian.
Good to see you.
No, good to see you. Right? If I do,
Yeah, I'm still here.
you're left with T. T is delta H over delta S, right? So the T that you want to solve is equal to delta H under the standard condition divided by delta S under the standard condition, which is going to be, it's going to be delta H on the top. Is this delta H? Let me clean my board. Do I write minus 92.0 kilojoule on the top? Yes? What is the unit of delta S? It's joule per Kelvin. Delta H is kilojoule. Does it make sense to use joule on the bottom and kilojoule on the top? So why don't I convert this to kilojoule? If I divide 199 joule by 1,000, I get number of kilojoules. Or I can actually use conversion. Why don't I use conversion factor? In other words, on the bottom, I'm writing delta S, which is minus 199 joule per Kelvin. And then I need to cancel joule, convert it to kilojoule. Joule and joule will cancel. I have kilojoule. And can I say 1 kilojoule is 1,000 joule, which is in a way dividing this by dividing 199 by 1,000, which is 1.99. And if you calculate this, then I can, joule and joule is gone, kilojoule and kilojoule will cancel each other, and 1 over K becomes K. Anybody gets 462? Another word, we are saying below 462, the reaction is non-spontaneous. At 462 becomes equilibrium. That means you start forming some product. And if I go above 462, reaction becomes spontaneous. That's why we do equilibrium calculation, to find out if a reaction is non-spontaneous, which is the case here. At room temperature, if you calculate the value of delta G, you see delta G is positive. Reaction is non-spontaneous.
If you ever need to get from kilojoules to joules per calorie or joules per whatever that is, do you always just multiply by 1,000?
Here, 1 kilojoule, 1 kilo of anything, is 1,000 joules. So
Okay.
that's, so you use this as a conversion factor.
Gotcha.
All right. You do this for any kilo of any unit into unit. Kilo, K means 1,000 here. That's the equivalent of K. Any other questions? Good question, Caleb. I go to next.